Physicists at the Australian National University have developed the most sensitive method ever for measuring the potential energy of an atom, within a hundredth of a decillionth of a joule, or 10 to 35 joule, and used it to validate one of the most tested theories in physics, quantum electrodynamics. The research, published this week in Science, relies on finding the color of laser light where a helium atom is invisible, and is an independent corroboration of previous methods used to test QED, which have involved measuring transitions from one atomic energy state to another. This invisibility is only for a specific atom and a specific color of light, so it couldn't be used to make an invisibility cloak that Harry Potter would use to investigate dark corners at Hogwarts, said lead author, Bryce Henson, a PhD student at a new research school of physics. But we were able to use to investigate some dark corners of QED theory. We were hoping to catch QED out, because there have been some previous discrepancies between theory and experiments, but it passed with a pretty good mark. Quantum electrodynamics, or QED, was developed in the late 1940s. However, hints that QED theory needed some improvement came from discrepancies in measurements of the size of the proton, which were mostly resolved in 2019. He measured the frequency of the oscillations with record precision, finding that interactions between the atoms and the laser light changed the frequency, as the laser color was varied. With the combination of an extremely high-resolution laser and atoms cooled to 80 billionths of a degree above absolute zero, 80 nanokelvin, the team achieved a sensitivity in their energy measurements that was 5 orders of magnitude less than energy of the atoms, around 10 to 35 joules, or a temperature. That's so small that I can't think of any phenomenon to compare it to. It's so far off the end of the scale, Mr. Henson said. With these measurements, the team were able to deduce very precise values for the invisibility color of helium. To compare their results with theoretical prediction for QED, they turned to Professor Li Yan Tang from the Chinese Academy of the Sciences in Wuhan and Professor Gordon Drake from the University of Windsor in Canada. In this quest they were more than successful, improving their uncertainty to a mere 1/40th of the latest experimental uncertainty, and singling out the QED contribution to the atom's invisibility frequency, which was 30 times larger than the experiment's uncertainty. The theoretical value was only slightly lower than the experimental value by 1.7 times the experimental uncertainty. Leader of the international collaboration, Professor Ken Baldwin from the ANU Research School of Physics, said that improvements to the experiment might help resolve the discrepancy, but would also hone an extraordinary tool that could illuminate QED and other theories. New tools for precision measurements often drive big changes in theoretical understanding down the track, Professor Baldwin said. B. M. Henson, J. A. Ross, K. F. Thomas, C. N. Kuhn, D. K. Shin, S. S. Hodgman, Yongwei Zhang, Li Yan Tang, G. W. F. Drake, A. T. Bondi, A. G. Truscott, K. G. H. Baldwin. Measurement of a helium tune-out frequency, an independent test of quantum electrodynamics. Science, 2022. 376, 6589, 199 doi. 10. 1126 Science. ABK 2502 Australian National University. Australian National University. 2022, April 8. Invisible helium atoms provide exquisitely sensitive test of fundamental theory. Science Daily. Retrieved April 8, 2022 from ift.tt/n4twmcx Australian National University. Thanks for watching. Please subscribe my channel for more videos.